Hey everyone, welcome to today's Explainer, where we're basically doing a knowledge unboxing. We flick switches and push buttons hundreds of times a day, but we rarely stop to think about the absolute engineering magic happening right beneath our fingertips. Today, we're uncovering the hidden switches of everyday life, specifically the secrets behind A contacts and B contacts. Even if you have absolutely zero background in electricity, don't worry. We're going to break this down so it's super easy and fun to understand. So, let's dive right in.
To kick things off, let me ask you a super relatable question. You know when you get up in the middle of the night for a glass of water, you open the fridge, and boom, that bright light turns on? But here is the real mystery. How exactly does that light turn off when you close the door? I mean, it's something we literally see every day, right? But it actually hides a fundamental secret of electrical engineering. When that door closes, it presses a tiny little switch inside. Keep that mystery in the back of your mind because we're going to solve it very soon.
Okay, to solve that fridge mystery, we first need to understand the absolute basics. Every piece of automation and electrical engineering out there relies on two fundamental states of a switch. It's either open, meaning disconnected, so the electricity can't flow, or it's closed, meaning connected, allowing the current to pass right through. The big question engineers ask is, what is the switch doing in its resting state? Like when nobody is touching it, is it stopping the electricity or letting it flow? This default state is literally the foundation of how machines are designed.
And that brings us to our very first star of the show, the A contact, also known as normally open or just NO for short. The name kind of gives it away, right? By default, it's normally open. Because there's a physical gap between the metal contacts, absolutely no electricity can flow unless you do something about it. And its resting state is completely silent, perfectly still, and totally blocking the current. Let's break down how this works in 3 simple steps. First, in its resting state, there's a physical gap, no electricity. Second, when you push it with your finger, bam! Your physical force overcomes a little spring inside, pushing the 2 metal pieces together. That's when the electricity flows. Third, the moment you let go, that tiny spring pushes back, snapping the contacts apart and instantly cutting the power. It's literally just your finger building a bridge for the electricity and then taking it away. Simple, right?
If you're still trying to picture it, just think about a water dispenser. When you want a cold drink, what do? You push and hold the button, right? As long as you're pressing it, the water flows. The second you lift your finger, the water stops immediately. An A contact works exactly the same way. You have to actively push it to make things happen. That active command is the whole point of an A contact.
So, where do we see these in real life? Honestly, they are everywhere. Think about your doorbell. It only rings while you're actually pressing it. Or the keyboard you type on. Every single keystroke is an A contact, telling the computer to print a letter. Even a car horn, it only blasts while you're pushing the steering wheel. Anytime you need to give a direct, active command to start something, you're relying on an A contact.
All right, now let's completely flip the script. Enter our second star, the B contact, or normally closed, usually just called NC. This little guy is the exact opposite of the A contact. As the name suggests, it's normally closed. That means if you just leave it alone, electricity is flowing through it 24/7. Even when you're not doing anything, the machine is already buzzing with active current.
This is where things get a little counterintuitive, but super fascinating. Step 1. Resting state. The spring is actually holding the contacts tightly together, so power is happily flowing. Step 2. When you push the button, your force actually pries those contacts apart, breaking the circuit and stopping the electricity. Step 3. Release it, and the spring forces them back together, turning the power back on. So with a B contact, pushing the button actually stops the action. Pretty wild, right?
The best way to visualize this? Imagine a garden hose with the water fully turned on. The water is just rushing through, completely uninterrupted. But then, you step hard on the hose. What happens? The flow is immediately cut off. When you lift your foot, the water rushes back. That's exactly how a B contact works. The electricity naturally wants to flow, and your physical action is what cuts it off. And boom, that finally solves our fridge mystery. When the fridge door is wide open, nobody is pressing the switch. Because it's a B contact, electricity is flowing by default, keeping the light on. But when you shut the heavy door, it literally presses the switch, just like stepping on that hose, cutting the power and turning off the light. We also see B contacts in those big red emergency stop buttons in factories, and even in home security window sensors where separating a magnet triggers an alarm. They are absolutely crucial for safety.
Let's put them side by side to really lock this in. An A contact defaults to open. Press it, and it turns on. It's a start command. You're telling the machine, hey, get to work. A B contact defaults to closed. Press it, and it turns off. It's a stop command. It's saying, whoa, danger, shut it down. This difference isn't just about wiring. It's a massive fail-safe design philosophy.
Now, I want you to think about a really serious what-if scenario. What if we took a highly dangerous factory conveyor belt and wired its emergency stop button using an A contact instead of a B contact? You might think, well, as long as pushing it sends a signal to the computer to stop, who cares, right? But oh man, that simple assumption could lead to an absolute catastrophe. Let's see why. Picture this. Deep in the factory, a rat chews through the wire connected to that emergency stop button. If it's an A contact, the circuit is already open by default, but now it's physically broken forever. Suddenly, a worker gets caught in the machine. They frantically smash the E-stop button. But absolutely nothing happens. Because the wire is severed, that stop command can never, ever reach the system. The machine just keeps running dangerously, and you've got a massive hazard on your hands.
This is exactly why engineers ask themselves one profound question. Is this just a simple command, or is it a life-saving failsafe? Choosing between an A contact and a B contact isn't just a random coin toss about where to plug a wire. It is a deep, intentional design philosophy meant to protect human lives and prepare for the absolute worst-case scenarios.
And that brings us to the brilliant concept of the failsafe. If you use a B contact for an emergency stop, power is constantly flowing. But what if that same rat chews the wire? The current instantly drops to zero. And here's the genius part. The machine's system interprets that sudden lack of current exactly the same way as someone smashing the e-stop button. It triggers an automatic, safe shutdown immediately. Even if the equipment physically breaks, it fails in a safe way. Honestly, that kind of engineering is just so cool.
All right, let's lighten the mood a bit. If A contacts and B contacts are so great at their individual jobs, what if we just smash them together? Well, engineers did exactly that and created the C contact, or changeover. It's basically a brilliant two-in-one deal packaged into a single relay. It gives industrial machines the best of both worlds in one tiny, clever component.
If you look at a C contact, you'll see three terminals. You've got COM, which is where the main power comes in. Then you've got your NO, the A contact, and your NC, the B contact. When a signal is sent to this relay, the switch snaps over. It breaks away from the B contact and instantly connects to the A contact. It's like flicking a switch on a railroad track to smoothly reroute a train. This lets machines seamlessly toggle power between two different devices, like instantly switching a machine's status light from a happy green to a warning red.
And that wraps up our knowledge unboxing for today. But honestly, the fun part starts right now. I want you to take a second, look around the room you're in. Look at your TV remote, your washing machine, the lamps on your desk. Which of those are hiding an A contact that needs your active push? And which ones are secretly using a B contact to keep you safe and make your life easier? Once you know the secret, the ordinary world around you suddenly looks a whole lot more fascinating. Keep that curiosity alive, and we'll see you next time with another explainer.